Yeah.
You wanted
So should I start now? क्या कुछ बोलोगे?
just sir, wait 1 minute.
Okay.
Okay, sir.
Should I start?
Yes, sir. Yes, sir.
Okay. So yes. So
Morning, sir.
good morning, everyone, and I think you will enjoy. And I yesterday there was two lectures and little bit hectic schedule you will have. You would have and hands-on session was also good. Dr. B.K. Rao actually demonstrated some uh, that, basic Linux command and. Although we can use now this the modern version of the recent version of Ubuntu is Windows also. So, but some commands this is really necessary to save time. So today's first lecture. So the schedule of today, the first lecture and it is being delivered by me. And second part that will be the hands-on session and uh, before for that hands-on session today we are going to install all the tools utilities and also that main sister tool on which we are going to work and that will be good and please uh, just learn that carefully because I have several queries from different part of India and also uh, from other countries that how to install that particular system parallel version especially and this tool is creating issue. So on the basis of our previous experience, we have designed some scripts and then we will share that script also and how to use that script and how to install all these tools. So this is the topic for today's hands-on session. So that is very important one. So it has to learn very carefully. And one thing that before that starting my talk, I just first thank to Dr. Gaurav and the team for inviting me. And one personal request to all the audience, all the participants, please mute your mic as well as that camera also because yesterday was sometimes so not was it was not a good moment when Dr. Pandey after so many requests Pandey sir agreed to give the talk and that talk is really very precious for all of us team and in between that talk some people were just roaming here and then they are in the street and just keeping on that camera and some mic was suddenly on so that disturbance moment was really not good. So please avoid this type of thing because we have very good speakers in the team and they all are experts. So um, also we have to motivate all the speakers to complete their talk with the time and take the benefit of their expertise. So please, I request you, the cooperation of all. And here, one line message generally I use in my different talks and different courses that happy learning, and we have to enjoy the learning. And for that, your cooperation and also the mutual interaction is very important. So you can ask you're curious in the group as well as in uh, this. This platform on which I am delivering this talk. So please cooperate and enjoy learning. Thank you. So let's begin this. The quantum transport. This is the buzzword nowadays being used. That quantum technology, quantum transport, quantum computing tactics. So here, this is very small part of that quantum technology that is known as the quantum transport, and I'm going to deliver some fundamentals of this quantum transport and the applications in that nano electronics. So this nano electronics, definitely we know about that electronics are different two terminal, three terminal devices, and now we have using that DFT and DFT based tools, we have n terminal devices. So I will just give some glimpse on this, uh, the devices or application of this quantum transport in the nanoelectronic devices, and how we can uh, run the program, or we can study any nanoelectronic materials or nanoelectronic devices by using this SISTA tool. We will discuss on these things. So anyway, so let's begin. So the first question, that is what is actually the quantum transport, and some terminology here I am going to use, and during hands-on session you will understand what actually this means. But these are the some terms. That is, one is that quantum coherent. So this term, this actually electron maintain electrons maintain the phase coherence across the device, and generally we use that the dual nature of electron. So in previously that electron was just a particle, but after quantum theory we are using that dual nature of electron behave like a particle as well as a wave. So here we are going to use the wave nature of electrons and the coherency of this electron across the device. And when we talk about the device, means we think about that the channel through which this electron flow, and this enabling quantum interference effect. And second, that nanoscale dimension, this is the term which we are using in quantum transport. So that device features comparable to electron wavelength, here that wave nature of electron, and that requiring full quantum treatment. And there is one term, that is non-equilibrium condition. So we know without that non-equilibrium condition, that the flow of water, a flow of voltage, current, this is not possible. So also we here we are going to use some condition to maintain this non-equilibrium. So we will apply bias drives the system away from equilibrium, creating current flow. And then we have we are going to use this open boundary challenge, because this requires modeling infinite electrons connection to infinite scattering region. So that scattering region, that the divides the channel. And the so quantum transport actually describes electron motion at the nanoscale under applied bias. So these are the terms I just used, and where the classical approach fundamentally break down. So the classical approach, that is for the bulk materials we use, and at this dimension, electrons behave as coherent waves rather than particle, and this is necessitating a full quantum mechanical treatment. So to understand that DFT-based study fully, uh, we must have the basic knowledge of quantum mechanics. So especially up to that the Schrodinger equation, and the application of that Schrodinger equation. So now the fundamental of this the transistor nanoelectronic devices. So just I am working on that, the title of things. So so the transistor fundamental, this is that building block. So we have classified that device in three parts, that the source, channel, and drain. And when we, this is just a diode, two terminal device, and when we connect with a gate, then this becomes that transistor. So this transistor structure contains a channel, that is actually the conductive region, and two large contacts. And these fundamental structures have remained consistent even at the transistor have shrunk dramatically in size. So in the classical physics also, or the classical devices, macro devices, we are using the same configuration, same structure. And also in the quantum computing or the quantum devices, where we are using quantum transport, we are going to use the same structure. And then we are familiar with that, the classical conductivity and the Doded formula. And that classical net conductivity, there we use that particle nature of that electrons, and that current flow due to that flow of that electron with a particular wire having cross section area A. And we defined that the conductivity, we defined that the resistivity, resistance, and other parameter based on the length of that wire as well as the cross section area of that wire. And one formula, that is the very well-known formula, where we use the carrier concentration and the relaxation time. And here we use that the concept of electron as an electron gas moving random here and there. So that sigma is equal to q square and tau by m. Here this tau is actually that mean free time or the relaxation time, and m is effective mass here, and n definitely indicates that the density of electrons, number of electrons per unit volume. And now that the transformation from this classical to quantum. So here in the quantum term, we use that ballistic transport term. So that ballistic flow, it is used in nanoscale devices. And here this electron flow transition from diffusive to ballistic transport. So in semiconductor physics or in physics, we use two types of current, a drift current and a diffusion current. But here in quantum physics, we have another one, that is this ballistic one, means there is no diffusion or collision type things, that directly that electron flow. So this fundamental shift requires new mathematical framework to alternatively that the model of conductance. And we, in spite of that classical conductance, we define this quantum conductance, and this quantum conductance is represented by ZV, and this is equivalent to Q square H multiplied by M. And here this Q and H, these are the fundamental constants, and M represent the number of effective channel available for the conductance. So this is the channel, means the number of path through which that electron can flow. And this the figure shows that the relation of that resistance and other things, that is the classical picture, and here we use that the quantum picture of that. So the resistance calculation for that, so this RB, that is the ballistic resistance we will have, and that is actually equal to H upon Q square 1 upon M, and that is 2 m kilo ohm, and just in the quantized terms. So this is the calculation, and for the detail, we have a good reference is there, that is by Supriyo Datta, and some contents I have taken from that. Uh, that so now that the length dependent in electron transport, so that coherency, it is electrons should coherent. That one term I used in the first slide. So this is that the common formula for this Z is equivalent to GB by 1 plus L upon lambda. So the condition. So depending on this L and lambda, we have um, value of this quantum conductance. So in very short devices, means when this L, that is the length of this channel, it is much less than lambda, that big free path. So this term, this can be ignored, and that the total conductance, that will be equal to the ballistic conductance. And there will be one intermediate device where the length of this channel, this increases, and uh, then this the ballistic conductance can be slightly uh, uh, transformed to that diffusive transport region, so diffusion conductance one can say. And if the device is long, means this lambda L is much greater than lambda, then the conductance becomes inversely proportional to length, and this is actually the classical behavior. So these terms actually one term which actually a bridge between that and the classical conductance and the quantum conductance. So ballistic and diffusive conductance are not two distinct category, but rather exist along a continuous and a device length. So when the length of that channel or that device changes, means that the properties of that conductance is transferred from that ballistic to that diffusive one, is that quantum to classical. So this is also in the we use in that the concept of quantum and the classical physics, and this is the same thing here. Now, some more terms that we should understand to know this quantum transport properly. That is that electrochemical potential term, that contact potential terms, and the equilibrium dynamics. So this is that schematic diagram of this left electrode and right electrode, and in between that channel is there. So in this current flow, this actually depends on this the understanding energy level inside the channel, and this energy level is uh, represented in terms of density of states. So what is that density of state? This is one term related to that solid state physics, and this is total number of available energy states per unit volume in that different that energy levels. So this is available energy states, and these states are continually distributed up to this Fermi level. And here, this mu1, this is the chemical potential of that left electrode, and mu2, that is the chemical potential of that the right electrode. And uh, when we use one potentials, when the drain contact energy levels are lowered by the amount of applied voltage. So when we apply that voltage uh, perpendicular to this, so that the direction of electric field is shown here. So that the level of this electrode, that potential level, that will drop down equivalent to QB. And mathematically, that mu1 and mu2, this is equivalent to Q multiplied by Vd, where this Vd is drift voltage. We are drain voltage. We can so actually the flow of this electron from left electrode to right electrode, this is controlled by this voltage, as well as this is actually based on equilibrium dynamic. So here when we apply this voltage, that from equilibrium to non-equilibrium condition is uh, generated, and due to that this current is start flowing, and these terms are related to the Fermi function. So this Fermi function F1 is equivalent to this, and this can be denoted as F naught E minus mu1, and F2 that can be denoted as F naught E minus mu2. So these are that some terms which we can get from some good solid state book. Fermi-Dirac function, Fermi function, these are the terms used here. So the mathematical framework for the current calculation. So the current calculation actually relies on integrating over all energy states and weighted by the difference in the Fermi function between uh, this left electrode and between these contexts, left electrode and right electrode. And this approach captures both quantum and classical aspect of electron transport. And the formula account for electron density, time spent in the channel, and occupation probability at edge energy levels. So here, uh, the current is integration. This is that mathematical term to interpret that current through that channel. So this I is equivalent to integration of dE, and this is that term q dE by 2t and to t, which is the function of energy, multiplied by the difference in the Fermi function in left electrode and right electrode. And conductance is mathematically defined as B is equal to Q squared dE, density of state by 2t multiplied by t, which is actually the function of E. So now there is one term used in quantum transport, that is non-equilibrium green function. So uh, quantum transport, we use that density functional based study. So the density functional theory also, as well as one additional term, that is non-equilibrium green function. And this non-equilibrium green function, this is a method stands as the gold standard for quantum transport simulation, because it is elegantly handle the fundamental challenge of nanoscale electron transport. So unlike alternative approach, this NEGF, this non-equilibrium green function, naturally incorporates open boundary condition essential for modeling a realistic device electrode interface. So in the device electrode interface, this non-equilibrium green function is used. So this is really a little bit mathematically complicated, and I am not going to give include all that mathematics related to this non-equilibrium green function, but you must have some idea about this non-equilibrium green function. So this energy provides access of this key physical quantities, including the transmission probabilities, current density, local density of states, of all critical for understanding device performance in the quantum level. So so the current calculations, by using this NEGF, we can calculate the current. So direct computation of this current calculation and nanoscale device is possible through this. And that quantum coherent, this preserves the quantum mechanical effect in quantum transport properties. And this also maintains this open boundary conditions. So we use here that semi-infinite electrodes connected to finite device region. So this the setup of this NAGF. So we use left electrode, and that is semi-infinite, and that left electrode, actually this is the source of electron, which is characterized by that the chemical potential, and it is represented as either mu1 or that mu L you can represent, and the self energy concerned with this, that is sigma L, and that is scattering region, that the center region, that is the active region, scattering region, the channel. There are several names are given. So this is actually the central device where quantum transport occurs, fully described by the Hamiltonian. This Hamiltonian is the term. Yesterday also, Professor Pandey has used that Hamiltonian, this the term, and the complete DFT and other mechanism. This is based on the Hamiltonian term. So here also, in the scattering region, we have this Hamiltonian HC, and that right electrode, definitely this is also that semi-infinite, and this actually drain for the electrons, and this characterized by the chemical potential, that is mu r and self energy. So this NAGF approach, this divide into system into three distinct regions, two semi-infinite electrodes and one finite scattering region. And this partitioning can reflect experimental reality. So in experimental device also we have uh, three parts. In almost that optoelectronic devices we get that two electrodes and the active center region. And this electrode region maintains equilibrium characterized by their respective this chemical potential. If chemical potential are identical, then the system is equilibrium. But when we have there is change in the chemical potential, then in equilibrium this position occurs, and that current will flow through that. So that's some key equations generally we use in NAGF. That is the retarded Green's function. This describes electron propagation through the device. And that left electrode self energy, this is denoted by these mathematical terms. This captures influence of semi-infinite electrode. And then this is transmission function. Similarly, that left and right, both this equation first, left and right, both equation. And that the transmission function is defined as this. This is actually the probability of electron transport at energy E, and this current uh, in order to get that IV curves, we have this current to be calculated, and this is calculated by Lendor but Buttiger formulas for current calculation. So this energy of formulas in bulk upon three this fundamental equation, and this retarded Green function these contain complete information about the system's response to external perturbation. And this self energy, this represents the electrode's influence on the central region, effectively embedding the finite device in infinite environment. And this transmission function, this gives the probability of electron transport at given energy. So when we study this transport property, then we have a plot of these IV curves and that transmission function, and we can use this sister tool to get all these things. Now we are using one utility that is inbuilt with the Sista, or one can say that Sista can be also be used in advanced form as a transistor. So this transistor is summation of sum of these two parts, trans plus Sista. So this trans means transport property. So when we use that Sista for the transport property, then this is known as transistor. So in the transistor, that NAGF, this non-equilibrium green function is implemented with this system, and this is integrated with the DFT. So this is seamlessly combines with the sister's efficient density functional framework, and that this bias handling is possible here. So this enables self-consistent calculations under a finite bias voltage. So that self-consistent calculation. Yesterday that Pandey sir's talk, there was the term this self-consistence calculation. We start from one gas density and then we start calculating. So that self-consistent calculation. Scalability. So this parallel implementation over handling large-scale quantum transport system. So that uh, transistor is showing this particular capability therein. So transistor extend the capability of sisters package. This is widely used implementation of density functional theory, and that to include quantum transport calculation. It represents the powerful tool for nanoscale devices and simulation by combining the efficiency of sisters localized basis approach. Now the workflow in the transistor. So to use that transistor, one general workflow we adopt. So we start with that. We have this is that configuration of device. So first we will design this device, that left electrode, and that the center one is our channel or the rectal region, and this one is the right hand side is the right electrode. And so first we start with the fabrication of this device, and for that definitely we use some utility to design this device, and today's hands-on session and also coming hands-on session we will show that how this device can be designed. And then we start with this electrode calculation. So this compute self-consistent DFT for each electrode separately. So this electrode calculation is primarily a DFT based calculation, and before that transistor we use this a DFT based calculation for electrode. And then this device structure setup. So build a central region including the buffer zone of electron. So that buffer zone means out of some this electrode layer, we can use some layers of that materials as a buffer layer to avoid the proper to avoid that direct contact between two electrodes. Uh, so then this NEGF run with the bias. So we apply this biasing one, and for the post processing, we use TB trans, and this TB trans utility, this gives the transmission parameters and the current versus voltage plot and the transport properties. So this transport workflow follows the logical progression of electrode preparation to the final analysis, and we will start with this fabrication, and this is three steps process. One, electrode run. Second, that the scattering run, the central region, and the final one, the third one is this TB trans based run to get IV curves and the transmission. So the geometry preparation. So one should take care of during the preparation of that device or the geometry of that transistor. So first one is that the electrode region. So this remember this that electrode must be periodic along transport direction. So initially that transport direction was along z-axis only, but nowadays transistor it is advanced enough. You can take that periodic direction either x-axis, y-axis, or z-axis in the three axis. So generally. By default, I use that Z direction as a periodic direction. And typically, bulk-like materials like metals or doped semiconductor, this must be used as a electrode. Remember this electrode must be a good electron donor and electron acceptor. So if you are using metal, and definitely in many devices, metal is used as a electrode, then that will be a good electrode. And sometimes you can use semiconductor also as a with a doped with for the electrode one. And then this requires separate calculation to determine electronic structure. In the central region, this contains the device of interest plus buffer zone, and that, that the central region might be any molecule, just like that DNA molecule yesterday we observed, and that buffer region must match the electrode unit cell exactly. So the buffer is actually the part of that extension of electrodes, and this also, the central region includes the defects, molecules, or nanostructures. So, the proper geometry preparation, this is very crucial for the accurate transport calculation. So, we have to take care of all these things. So that electrode specification. So generally in input file, definitely we will have one input file similar to that transistor. So we will have this the block for that electrode, that is TS electrode, and then second one is that for the voltage setting we have to one flag or one line for the voltage setting, and for to control this transport option we will have several lines included in this input file. So definitely we have two input files, one separately for electrode one, and second input file that is known as a sketch input file, and that input file includes this the voltage setting, and that the complete setup of that device, as well as some parameters which is required for the transport calculation. So electrode calculation. So this is periodic DFT calculation, one thing, and this generate the Hamiltonian and overlap, and this actually generate this extract HNS, and self energy computation is there, and store for the device calculation. So it gives a result in terms of HSL or HSR files, and this one file from this electron calculation, it is further used by scattering calculation for NEGF simulation. So that is that file is nowadays it is used as HSX in recent version, but before that it was HS SC like that. It was earlier. Yeah, I just forgot to write here. Anyway, so central region calculation. So we will first start with that, initialize with that electrode information. So that information we take from that electrode. And second, we start with that initial density metric gauge, and then we apply bias potential and self consistence. This NEGF plus a DFT loop is used. So the central region calculation represents the core of transistor's functionality. It incorporates the device itself along with the portion of each electrode, solving the coupled this DFT plus NG uh, non-equilibrium green function equation self-consistency under applied bias. And the post-processing, we use this TB trans for the post-processing, and it calculates this transmission function, the current calculation, the local density of state, and some special functions also with that. And this TB trans, this is a post-processing tool that extract physical observation from transistor output. System setup for transport calculation. So this is a very crucial part, and just I am repeating that term frequently, that we have this LCR part at infinite system. L is left, C is the central region, R is that the right electrode, and matrix formula we use that, and self energy calculation is from for both electrodes, and the self consistent solution is for that the central region. And this is that schematic diagram taken from, I think, some books, and system framework is there, and also that null extension is used in the central part, and the computational efficiency this is required for that. So the finite range of basis function, it enables effective efficient calculation for a large system, making it suitable for a realistic uh, nano electronic devices simulation. So definitely this is computationally costly with compared to SISTA, but a really wonderful utility available with SISTA to calculate transport. So electrode configuration. So these are some terms used in electrode configuration. So the system name and basis state, electricity, energy, exchange correlation terms, K-point sampling, atomic configuration. So these are the terms we use. And what are actually these terms during that hands-on session we will discuss about all these things. And that device configuration for transport simulation. So we have a complete system, and that one example I have taken is that 18 atoms scattering region, and that latest configuration. So these are the terms generally we use in input file. And this device configuration combines obviously that one active region is sandwiched between left and right electrodes. So some case studies. One case study from my group, that is one gas sensor device. So in the application of this quantum transport, generally we use for the sensing applications, and for that definitely we will have one central region with two electrodes. So here, as a gas study, I am representing here some just output from one of my paper. So here that SnH2 monolayer, which is actually the white doped, and I think we have taken that 4x4 cross 1 monolayer. So, and then after optimizing this monolayer and the doped monolayer, this interaction of these gas molecules like carbon carbon monoxide, NO, carbon dioxide, NO2, and NS3 on that. And initially we study this by DFT, and calculate these absorption properties, that's absorption terms, and some DAS, PDAS, absorption mechanism, and how that charge is transferred, charge density analysis. So these are the common study in DFT-based systems. And after that, we study its transport properties, and gauge the effect of the presence of these gas molecules on the interaction of these gas molecules on this white doped SnH2 monolayer. And for that, we use this transistor tool with implemented with system. And yeah, that I mentioned here, yes. So we first construct that supercell by 4x4x1. So how to construct this supercell, we will discuss in that hands-on session. And then we take this K-point sampling as a 5x5x1 for geometrical optimization, and 15x15x1 for time method. And 10 मिनट बता दें. And that 15 cross 15 cross 1 for electronic properties using this scheme. So this is monk horse pack scheme for the K-point sampling. And electrode calculation we use. So we are using that electrode, that 2D graphene. So graphene is actually zero band gap semiconductor. It can be used for electrode material. So we use this one, and here we are using that the layer of carbons containing 44 carbon atoms, and the voltage applied, this is from 0 to 1 volt, and the gap of 0.2. So we have observed this IV curves in this potential range. And this is some result from that paper. So also we observed, try to get that magnetic behavior also. So but there is no change in that dust plot, means it's magnetically insulator. And then this total density of state we are observing here. So it's showing that metallic type behavior, and that charge density distribution we have observed. So all these are that the study using that SISTA tool. And then this is that the output from the transistor one, and the right hand side uh, this is that our monolayer, and that the, at the top of that monolayer these gas molecules are there. And this is the bottom we are showing here in the right bottom, that is two electrodes, the graphene electrodes, and in between that SNH2 white dot is here. And these are that IV curves with different gas molecules. So pure, so that for pure SNH2 wide of the SNH2, this valid curve is here. And when we interact with carbon dioxide, its IV curve changes, means it is showing, it is sensing actually, it is being sensed by this monolayer we can represent here. So these are that different IV curves for different gas molecules. So that transport properties calculation we observed in that peak. So 0.62 microampere peak current we observed, and also that the reverse current, peak reverse current was less than the forward current. And so we have observed that the negative voltage direction as well as positive voltage direction, and peak voltage is at zero point 0.6. So the transport properties of wide of the SNS2 system, so distinct current voltage characteristic, and that vary significantly with the different absorbed gas molecules. And what is the key observation? In all IV curves, in the presence of negative differential resistance NDR, so that negative, that sharp drop in the curve, that is negative differential condition is there. And this NDR phenomenon is attributed to transmission and tunneling effect between conjunction band during transport calculation. And the second one example is that is the molecular twisting effect on ketone charge. So this is another cell. Again, we are using that graphenous electrode, and in between we have that dimer of ketone. This is a really wonderful material. That is that biocompatible material, and so what we are observing here, first we studied its general that electronic properties by using a system, and then we studied the transport properties, and we start rotating that molecule. So we fix one monomer and just start rotating that second monomer with a certain angle. So we start with 15, 30 and other angles, and observe the change in its IV curves, so change in its behavior. So this is that output. So by rotating that molecules in that homolumo plot, that beautiful plot, and how we can get this during hands-on session, we will show that. And this IV curve at a different angle rotation, and this type of behavior is known as the molecular switching. So in the molecular level switching, when we rotate it in a certain molecule, and its current IV curve changes drastically, then this is known as the molecular switching characteristic. So we have just reported that this ketone can also be used as molecular switching devices. Anyway, so thank you all, and practice well, learn well, apply well, and I think it's yeah, within this time. Good one. Now, few questions we can. Yeah, any question?
Dear participants, if you have any question, you can ask.
Or you can drop the message in group.
Drop the message.
So time to time we can reply that, and even from 11 we have to start that hands-on session also. Uh, I think there is no question in chat box also. Okay, so I think we should conclude. Thank you all.
Okay, sir. Thank you, sir. Thank you. Thank you for this wonderful session, sir. So we'll take a 10 minutes break, sir.
Yeah, and then at 11:05 we will start the tension session. Okay, so your system is working good ना? ले बढ़िया सेट हो गया है ना?
Okay, sir.
ले में कोई हाँ, okay.
Yes, sir. Yes, sir.
So do we start now?
Yes, sir.
So welcome back. Thanks again. So let's begin the second session, that is the hands-on session. And, as per the schedule, we are going to install some utility. And, yesterday, that the Linux operating system it is introduced properly. I think so this is my desktop. Here some icons are there, and also this is the boundary, and you can use this. Yes, I mentioned that you can enjoy this Linux operating system as window also, except that this command window. So this command window can be opened by using different methods, by using this control tree and so many things, and even that here. And before installing Sista, that is the main tool, I generally request or recommend that please go through the manual. Its manual is really well designed, well written, and also one should go through that the website of Sista. So Sista web page. Visit that web page, and then you can Sista, and you can get the code from here. That's Sista 5. We are going to install the Sista 5.4.0. It's a second major reason of this works, and really it's working good. We are using this. And also some binary installations are also there. And even if you are familiar with Python and Python based tool, then you can use Honda to install that. And, documentation part is here, so that manual is here, and some documentation pages, and some tutorials on from different workshops, and after that system beginning from 12 to now 2014, I think, 24. There are so many publications are also based there. System mailing list is here, and you can you can post your question. And also there is one documentation page. And, here this page is well designed, line by line everything is mentioned here. Although it's written systematically, but it's a little bit difficult to understand. But after attending this FTP, you will be able to understand each and every terms given to this one. So this is that the help available to you. And another thing to zero, I have designed one YouTube channel, and people are using that to do them. And, so you can go through this channel also. And, so yeah. Uh, okay. Okay. Check. Yeah. So this is the mic setting. Now voice is okay. This is
Yes, sir. Yes, sir. Yes.
channel, and so just type on that YouTube that Sister India with my name Mohan, then you will get this, and contents are there to help you all. Also, some of the playlists available there. That 5 minute DFT. So these are some short videos to help you. You can go through this. Really, people are enjoying this channel, and I'm getting good response without asking for the subscription and subscribe that and like that. People are automatically subscribing this, and now we have about 1800 users of this channel, and people are using. Time to time, I'm uploading good lectures on this. So, in any part, if you are not able to catch that, so catch me or understand, then you can go to this channel and you can get good contents to understand. Anyway, so these are the part you are going to use and you are going to learn. So first of all, what are the tools we are going to install today? And Mr. Sajal will help me, assist me to install all these things. So, so this is my desktop, and let me. I have some small PPT also. Yeah, this is that, PPT. Yeah, okay, good. I have. So here, so this hands-on session is to how to install pre and post processing tools along with the system. So the main tool system we will install, and for that we are going to use that the higher version, that is the 5.4.0. And the pre and post processing utility means before using system we need some tools that is known as the pre-processing utility, and after running system, after optimizing that material, we use some post-processing utility to extract data, to plot the data. That is the post-processing. So all the pre and post-processing utility we are going to install today, and definitely the system. Then some tools generally we use, that is GDIS, XMGrace, XCrystal, Vista, AC, and some other tools also. And to help people, we have designed some script. And I think Sajal has shared that script to the group, and you can download that in your system, and you are going to use that. But before using that script, you should learn the basic components of system installing, as well as the installing of all these tools. So the fundamental of DFT, you are familiar with this DFT. This is a computational quantum mechanical modeling method, and we are using this to study the material. And here we are just transforming many body particle solution using Schrodinger equation to Poisson equation, where we have charge density parameter in spite of wave function. And this DFT is implemented in system. This is one Spanish based tool, and this actually balance the computational power as well as that accuracy of the output. So this is really valuable for studying nanomaterials, surfaces, biological molecules, this periodic and non-periodic those type of systems with some high number of more number of agents. And we know that the system workflow. So this will be again detailed by Dr. Imran tomorrow, that input file FG of the things, and system calculation. So first we design input file, and then we start system calculation, and then we will have some output files. So for creating that input file, the tools we are using, that tools are known as pre-processing tools. And after system calculation, we have some output files, and to extract these output data, we are using post-processing utilities. So pre-processing, that is the structure creation, and also we have this for structure creation, that we use GDIS, Avogadro, AAC, JMOL. So that generally we use this GDIS. This is really wonderful tool. And the AAC, this is really a flexible and good tool. And one thing I would like to mention here, that all these tools we are using, these are free of cost. And the JMOL. So if you want to design some molecule type things or polymeric material that is non-periodic, then you can use Avogadro, and also JMOL can be used. So these are some pre-processing utility for the material design. And in my courses, or in this case, we use generally GDIS and ASC. And there's some format conversion utilities are also there. So we have this XYZ, that is coordinate of molecules, and the CIF file, that is crystallographic information file, and then some utilities open label C2X and GDIS. These are the tools to convert one file format to another file format. Vesta can be also. And then the parameter selections. So we have some parameter selection. We can use some default parameters. So these are that by using some sample input file, you can select several default parameters to create different file. For the post-processing utility, for the data extraction, we use generally that XMGRACE for plotting, and data extraction definitely that GTIS, XCrystal, Vesta, and these are that comes in. For the property calculation, there are so many inbuilt tools are available with the Sista package. So, for example, that optical properties, magnetic properties, charge density calculation. So for this calculation, there are so many inbuilt post-processing utilities are available. So there is no need of installation of that separately. It will be installed along with the system installation. So these are used for that property calculation. For example, today that transport property. So that TB trans we are using with the transistor. So the TB trans is inbuilt with the system, and it is pre-installed with parallel to that system installation. So installing Sista and the tools on Ubuntu. And one thing we are using here that Ubuntu 22.04, and before that we were using that 20.04, but that higher version of this Sista is not compatible with that lower version of Ubuntu, and even that the higher version of Ubuntu is available, that is 24 or 4.04, and some tools that the higher version is not compatible. That's why this we have checked that this 22.04 is good for this version of the Sista and related tools. So definitely, before installing Sista, we need to install some libraries, and these are known as system dependencies. So the first portion, that the first part which we will start installing is that it's a dependency, and I think yesterday Dr. Keshav has given that is command for installation, and there that sudo apt install. This term is used for that installation. So for pre-processing utilities, pre-installation utilities, dependencies can be installed by build essential, G4tran unit, and that OpenMPI, and these are can be used. So this is that command, and in that practice session we will see, and then we will install this one. And that some Python-based tools we can use. So separately, that Python-based tool can be installed by using Conda, Peep. So if you are Python user, then we can also use that Python-based utility to learn this system. And really, that is easy to use. So prerequisite and system requirement. So definitely, as I mentioned, an operating system. Even if you are CentOS user, then you should use CentOS 820 plus, and other some modern Linux operating system you can use. And some mathematical libraries like BLAS, LAPAC libraries, and all these are mentioned in manual also. And the Scala Park for parallel processing, that MPI, MPICS. So computer persons are familiar with these terms, but you should at least know about these terms. We are using that NetCDF, we are using CMake, and you should Google it. What is actually that NetCDF, CMake, and why we need these, and what is the advancement of it, because everything cannot be covered in this particular 90-minute this hands-on session. But the terms, whatever I'm using, these terms are important terms, and you can use that there several AI utilities to know what is the use of CMake, NetCDF, and OpenM, what is the role of this OpenMPI, MPSC, like that. And also that compilers like C, C++, and that G4 we are going to use. And if you have some commercial compilers like Intel i4 or Photon compiling, then it's good. Otherwise, as I mentioned, that I'm using everything free of cost. So that first for installation, we will download this system from its official website, and then that GitHub repository is also available. And after downloading and, this some help file is also there, that install.md readme file is there. In every Linux-based tool, the help file is mentioned as either that readme file or this type of install.md type file. So when you are using any utility based on that Linux, then everything is there in that folder. So open that folder and try to get the information given there, and automatically you can start running that. And then there are some commands to install that dependency. So that sudo apt install build essential gfortran and pci. Some mathematical library can be installed by using sudo apt install this, and that netcdf support. So we can install these one. So by using single command, the several libraries and that dependencies can be installed. That to build system, we can install that CMake also. So might be that all these that CMake is available in your system, but before starting that system installation, we must have this installed in your system. Then we can configure that system by using this CMake. So this is that command, and Sajal will show you how to use all these things on the terminal. I'm just showing here the glimpse what are that tools we are going to install, which are going to help to install that system on your system. It's not time taking; it just takes 5 to 15 minutes, depending on your RAM. And then we can export all this utility library to your bin directory for parallel compilation. As I mentioned, we are going to use parallel compilation because we are going to use all the processors available in our system. I have 8 processors, so if we install that in series, means out of 8 processor, I will only install the single one. I will only use that single processor. So if I want to use all the processor, then I will definitely perform this parallel compilation. So this is that installing system, the final one, and it will take 5 to 15 minutes, and this will install 100 plus modules, and the binary size it's about 20 MB on your system. So the basic execution, then after installing, we will check it is properly installed or not, and it's a running series or parallel. So we will check how we that. So these are that related to that system, the first part. So the second part, then we are going to install that this utility like GDI. This is a very good visualizing and editing tools, and you can go through its web page GDIS, and this is really having a good interface with the system. It actually directly gives that system input file, and the command is simple enough that sudo apt install GDI. This will be installed. So installation of this tool, it is not very difficult. Second, this action trace. This is two-dimensional plotting tool, and generally I prefer to use this plotting tool. And people are using Origin and other commercial plotting tools. Those commercial plotting tools are also good, and those are window compatible. Also, people are using action trace in Windows, but this action trace, this is two-dimensional plotting tool, and generally we use this for our computational work. And for publication process, this actually uh, gives various formats of that images, that is PostScript, PDF, PNG, SVG. So really good thing, and definitely we have a single line command to install this, that is sudo apt install this. Then XCrystal, this is interactive tool to crystal visualization, crystalline structure and densities. This is a short form known as XCrystal. It's compatible with the system, and installation is definitely simple enough. Sudo apt install XCrystal, and this tools actually use helps us to uh, visualize that crystal structure, as well as during that band plot analysis we use this, and charge density plotting we use this. So as a post processing utility, it is really wonderful tool. Then Vesta, people are using this Vesta as pre and post processing utility both. So that designing heterostructure or transforming the one phase to another phase, this mesh is used, and for post processing, definitely for visualization of charge density as well as crystal structure, measurement of bond and bond angles, everything is performed can be performed by using this type. This also free of cost, and its installation is little bit tricky because its library always changes. So one method which we are using today, it's not used, cannot be used tomorrow. So sometime it is used. Otherwise, many times the installation process changes. So let us say today what will be the method we can use. AC, this is Python based tool, and this is atomic simulation environment, and this is compatible with so many other DFT based tools, including Sista. So generally, we use this ASC for designing of that material as well as post processing of that material, visualizing of that material. Really, it's versatile, flexible. Molden, this is also good visualization and analysis tool. So many tools we are using, and this is also good for spectral analysis and noise spectrum. And it is integrated with system. Orbital visualization is also good for and JMOL and JSMOL. So this JMOL, even you can design that polymer or that molecular system by using this JMOL. So it's also a wonderful tool. GNU plot. So you can use this GNU plot along with that Exxon Grace. Exxon Grace is also plotting tool. GNU plot is another plotting tool, and you can install this by using a simple command, that is sudo apt install. VMT and Obito, these are also good tools, but computationally a little bit costly. And for molecular dynamic simulation, that VMT is good. And to install this, we have to first ask for its file to the developer. So it's not possible to install today here, but if you are interested, you can go to its web page and register there, and it's a free of cost. And ask the people to send the file, and you can install by the method given there. Virtual Nano Lab, this is a commercial tool with a TK, but not possible to install today, but it's also a good one. And also the Avogadro you can install today. So this is a really good tool to design that polymeric material, molecular material especially. So crystalline and crystalline both material it is useful. And the installation method is simple. So you have to install. So that's these are some visualization tool. So in workflow, we will first design the material, we'll run system design input file, then run system, and after running system, the visualization and then extracting of data is important. For bend structure, we use XML. So all these tools, whatever we are installing today, we are presenting today, we are using in our DFT-based study, and I promise you will be able to use all this utility after this activity. So some troubleshooting, so some mismatching library, compilation error, and OpenGL, this type of permission issues, this type of things can be shown on the computer screen as a troubleshooting error, and it's a very simple, and you can go over that these errors by a simple function. We are here to help you for this troubleshooting. So So this is the summary. So we are using that structured visualization and data analysis and for the automation. So, so let's begin. And if you face any difficulty during that installation, so I will recommend that you should open your that group WhatsApp group in your system, and just if you are using 20.04, then you can use print screen option, and here just print screen option, and then select that particular place here and there, and just click here and paste in the group. So that will show we will be able to observe, look on your own uh, system that error. So then we can help. So this is the method to share your errors, and I think some people are already familiar with these terms or this utility. So if possible, please help others to install all these tools, and if you're getting some errors. Anyway, so yes, Sajal, please continue on that command window and install all these utilities along with system step by step and a little bit slower. Okay, so now over to Sajal. Sajal, are you there now? Sajal, hello. Morning. Just a minute.
जी सर, जी सर.
Okay. So can you continue now?
Yes sir, I am continuing sir.
Okay. I'm here to help you anyway, but
Okay sir, okay sir.
you can do this. Okay, continue, please.
Some messages in the WhatsApp chat box. You have to open the terminal. Please open your terminal. Hello, am I audible? Hello.
Yes, Sajal, you're audible. Your voice is okay.
Please open your terminal by pressing Control plus key simultaneously, and please open a terminal.
I think you can share your screen now. Share your screen.
Sir, if any one of the participants can share their screen, I can proceed, sir.
Okay, so you are not sharing your screen
No,
for demonstration.
I am not sharing.
Okay, but it will be a little bit difficult, no? That's it.
Okay, sir. Then I am trying to share my screen.
The thing will be good if you use share that screen in the type and then simultaneously they will use that.
Okay, sir. Okay.
Try please.
Please wait for 2 or
So this is my desktop, and since all the utilities have been installed in a system, this is that command window. Increase the size of this command window by pressing Control Shift and plus sign. So just let me increase the size of this. And as mentioned yesterday by Dr. Keshav, that you can use this command ls. So frequently you will use this command ls to list out whatever that files, folders available on your system that will be shown by using this command. So many files and folders are available here. And also that Mr. Sajal has shared the list of commands which we are going to use. So one by one, we can use all these commands to install different utilities. So first, let us download the first script, and this script will definitely this is available in my system. So just click here and download on your system, and this script is available in my system, and I think it should be somewhere. So I have so many scripts. That is, this is for the 5.2.2, and this is that script. So here all the informations have been given, whatever I have mentioned in my presentation. That dependencies, the first part, this will update the system and install dependencies, and then this will download that system 5.4.0, and this will configure this system. So before that, let me delete whatever the system available in my system, and let me check, because in my system it's already installed. So this will definitely show some error sometimes. So now I have deleted my folder of that system 5.4.0, and, and I just remove that folder by using that the way in general we use in window. So just by clicking mouse here and there, and you can create folders, you can create some file. So I have just deleted this, and I want to open that script on this command window. So how to open this command window? Just right click here and go to this open in terminal. So you can click here by using this control T. Also you can open this, and here I have one icon available in this part. So if you want to add this icon on this favorite part, then you can go to this 3 by 3 dots, and here all the tools available in your system that will be visualized here. And terminal, so just type here that term. So this terminal will be opened, and now you can add this. So I am removing first it from this, and then let me first close this. So this terminal is not available here. Now I'm opening here and typing this term. Yeah, so this is the terminal, and then by right clicking this, now I can add this object. So this will be now available in this fabric. So uh, there are several ways to open this terminal in different windows. I have added this terminal by using this command. So let me open one terminal here, and this terminal, and I am just increasing the size and else. So do this on your system, so you will have different file system available on your computer system. And then let me search that is script available on this one, and this is just by using my mouse, I'm searching this. So this is that script we are going to use. So first of all, download this script on your system. It's shared by Mr. Sajal to the group, and just by double clicking that, you can watch, you can observe all the lines available there. And please do not add some lines or delete any line from that script, because it is not right protected. Anyone can modify that, and whatever that script, use that as it is. So this is that script I'm going to use. So the first command using here is chmod plus x, and this mlf script. So even I can copy, use this method. So this is that script. So let me copy this by the method we adopted. So this is the command number one, and I'm just copying this command to the group. Here is the first command we are going to use. And this is also mentioned in the script. And then press enter. So nothing will appear. So this, what is the meaning of this command? This change mode, it is actually converting this file to the executable file, binary file. So when you download any this type of file and you want to use as a tool, then just you have to change its nature by using change mode. Chmod means change mode. Now the command number second, that is dot slash, and the same. So this is that script we have converted this. So I think the first commands people have completed, and then use the second one, and enter that. Oh, sorry, yes, I have to delete all these. Sorry. Yeah. So that dot slash and this is script. So this will ask for the root password. So you have to ask your administrator of your computer system, or during installation, what is that root password given to your system. So I have, I'm just giving the password, and remember this, nothing will be uh, shown typed on that screen. So carefully type whatever that password is, because it's case sensitive, and if there is some typo error, then that will be issue. Yeah, but before that, check whether your internet connectivity is proper or not. I was just avoiding this because I'm using this internet from my mobile, uh, and this will take time depending on your internet speed. So let us see if no error is shown, means it is installed. And many times it creates error in my system, that some errors are showing because I have played so many things with my system. So you can report in the group these commands are running or not. So in my case, this is held, and because of some errors mentioned here, and this is because of that internet connectivity held in my system. So, but if your internet connectivity is proper, then must be installed. So check your system, it's working or not. So I'm just waiting for your response. If some errors are showing, just take that screenshot and share in the group. I'm waiting. So in between, let me, and anyone from that lab, please you can report me. Actually, I have already added executable in my system path, so these are that here. So if you have some error, then ChatGPT is ready to help to understand those lines. Everything is going good so far. So, copy this. Let us see what is ChatGPT. Library. Okay, so because of this, I'm using check again. This is that issue. Anyway, so I will resolve this, but so your so your review. Yes, I think the surgery is ready.
Good
So
morning,
you are
sir.
ready, Sajal?
I am sorry
That's
for
not
the inconvenience happened. Am I audible?
okay. Yeah, yeah. So you are ready now.
Yes,
Can you
sir.
come
Yes.
out? Because all the tools are
Uh,
installed in my system, so this type of error will show, and the people
yes, yes, yes.
will be confused.
Please let me to share my screen.
Okay.
Is my screen visible?
Yes, yes.
Yes. We are going to install the pre-processing and post-processing tool for siesta calculation one by one. First of all, we have to update our system. Press this sudo apt-get update. I have sent all the
First,
commands in the
let me,
group.
Sajal, first let me check whether that script is completed or it is broken.
Sir,
I think
actually,
people are running
this
that
is
script.
for
No, no,
this is
I
for
have just mentioned one command for that script
okay,
running.
okay, sir, okay, sir,
So
okay,
to
sir,
wait for something in the uh,
okay, sir.
first take the report from their side. It's running or not.
Dear participants, please
Brother?
mention if the installation process has been completed or not.
Send message.
Sajal sir, it has been installed in my system.
Okay, sir, okay, sir. Very nice, sir.
But regarding, there are some issues arises with the CMake, which I have resolved somehow.
Okay, okay. Somehow you can share your experience in the group so that all can resolve following this way.
Okay, okay, sir. I am sharing. I am sharing in the WhatsApp group, sir.
Definitely, definitely. Please share. Dear participants, if you face any issue, please type the commands as shared by Dr. Swarnadeep Bishas in the group and report. And what is the status of the offline participants? If anyone can report for the offline participants. Has anyone completed the installation process? Please report in the group. Has someone installed the software? Dear participants, dear participants, before installing the siesta script, we should proceed to install the visualization tool and pre-processing tools first. Let's first install these tools one by one. First of all, please copy sudo apt-get update in your terminal and press enter. My system is already up to date. Is this process complete for everyone? Dear participants, please comment in the chat box or unmute your mic.
एक मैं बोलता हूँ सर उनके भी आपकी। Done. Avogadro. Avogadro is not installing, getting some problems here.
Okay, okay. Avogadro. And rest of the process has been completed.
Yes, yes, sir.
Okay, okay.
Avogadro 2.
Just, just, just a minute. Just a minute.
This Avogadro 2 you.
Hello. Please, please type the command again to install Avogadro and press Avogadro in your terminal to check whether the Avogadro has been installed or not. And other participants, please comment. After that, sudo apt get install make, then cmake. Since all the processes have been completed in my system, so no things are happening. Then install gcc, g++, g fortran, gdis, grace, expedient, sir. Any update, sir? All the processes are completing well. Is there any issue regarding excretion?
Completed, sir, here.
Ex-Christian completed, J-Pol is also completed.
Okay, okay. And what about
Uh,
Malden?
this is Holden is not completed. It is getting error.
Molden is getting error, sir.
Okay, okay. Please retry after some time. There might be some internet issue. And what about Avogadro?
Avogadro is done, sir.
Okay, okay. We can retry Malden after some time. Okay, and Avogadro. Wine 64. Now download Vesta from this website.
Holden installed.
Very nice, very nice. Those who have already installed the pre-processing and post-processing tools, please try to install Siesta. Has anyone downloaded Vesta tar file and try to untar?
Completed, sir. Completed, sir.
Okay, okay, okay. And those who are able to use the folders, they are requested to go to the Vesta folder and type dot slash Vesta, VESTA, all caps. And those who are using terminal or WSL, they have to go to the Vesta folder making CD commands.
So all utilities have been installed. Express done is okay.
Sir, Vista is also installed.
So it is. It has been given the path, na Vesta. And so just directly by using Vesta, one can open that Vesta or dot slash
No,
Vesta.
sir. Actually, sir, after downloading from JP Minerals website, after
Yeah. I
unzipping,
just watched. Yeah. So if we give that the binary file to that export to that bin one, give the path, then I think
yes, sir,
that will
yes,
be directly. This can be opened, is it? By using the
yes,
export
sir, yes,
command.
sir,
But try this.
yes, sir, sir. But this has not been completed, sir.
Okay, Vesta has not completed.
Vesta, after
Vesta.
downloading, it has been completed, but its path has not been given to Bash RC, sir.
Okay. So just to give that the path and try that. You can add that path in the PRC, na?
Okay, sir.
Yes.
Okay.
Yeah.
Their participants go to the Vesta folder and open terminal there and type PWD, means present working directory. Then you can view this kind of name. Then you have to go to the home directory, simply making cd and type gedit bash rc. At the extreme end, we have to add this path.
This one path. First, change it in the in form of binary CH mode, then add the path.
Okay, sir. Okay, sir.
This is the method. Different terms we can. Even that rename is small Vesta. Uh,
Okay, sir. Okay, sir.
that should work probably.
Sir, I have renamed
Okay.
all caps Vesta with Vesta, but after giving this command, it is not working.
You change the mode, CH mode,
No, sir.
and then link with the path. CH mode Vesta. I think it should work. then give the path to that BRC. Then this will like this. Otherwise, people will use to write the correction in BRC. Then small waste. Open here. Path here. You have given that path there. Next, you have to replace capital waste of small waste. Open that in a text file BRC, text file BRC. Open that as in the gedit.
Bash RC, sir.
Yes. Here you have given that the path there, the capital wastage there. I think it should work, but there is some issue. The path is where is that waste? With that, you have to write that it should take. Yeah,
Best start.
it's everything is good. I think it should work. Anyways, forget about it. Just people should
Okay,
use
sir.
the library. Otherwise, we have some other installation.
Okay, sir. All are requested to repeat the siesta installation process again if the issue
When
is resolved.
and if some error is there, then please report in the group. And it's already 1 o'clock. And practicing is important. Practicing is important. So please practice. So installation is okay. Run that script. This is the only way to install. And if you are getting some error, either if you can take the help of ChatGPT, then use that. Otherwise, just report here. We are here to help you. डॉक्टर गौरव पांडे सर का वीडियो मिला क्या ड्यूरिंग इट
नहीं सर, नहीं सर।
सर को मैंने कहा था वो ऑटो सेव हुआ होगा मैंने क्योंकि सर बोले कि इसमें तो कोई ऑप्शन नहीं दिखा रहा है ऑटो सेव का मैं बोले सर ये जो टूल्स रहते हैं जैसे रिकॉर्डर जो रहता है वो ऑटो सेव करता है उसका फोल्डर रहता है हाँ, ठीक है मैं सर्च करके देखता हूँ करके पीपीटी तो भेजें टाइम वी विल time to time we will see that hands are different hand sensation. So generally we use that GDIS, AAC, system is okay. If you have installed the system properly, then you can verify by using a simple command like system API system. So tomorrow I think I will take that hand sensation or Dr. Imran will take care of this. Let's hope so. Everything will be good. Maintain continuity and happy learning. If there is any question, queries, please don't hesitate to ask. Even that in our session, we have mentioned that 90 minutes hands-on session will be there. In 20 minutes, one-to-one discussion session will be there. Yes, generally we use in our classes. So by different course. This is the trend. Generally, I give a talk, and then that hands-on session, and then a discussion session is there after that. So, in that discussion session, we discuss about the issues we are facing during the talk as well as in the hands-on session. So, please make a habit to take part in the discussion session. So please, if you have any queries, any question, feel free to ask. No one has some setbacks. There are 16. Okay, chatbots there is completed all, not installed. Very good. Some comments we have received from comment box. It's good. I think everything will work fine. So anyway, so let's conclude, Dr. Gaurav. So see you tomorrow. Thank you all, and happy learning.
Thank you very much.
Thank you, sir. I'll share this video to